In this video, we're going to take a look at Unit 7, where we're talking about Chapter 8 on proportional reasoning. In particular, this particular video is going to look at sections 8.1 and 8.2, Part 2, where we've been comparing rates. In these lessons, we've been looking at how to represent rates, how to interpret them, how to compare them, and then how to use them when we're solving problems. Now, in this particular video, which is Part 2 of the original, we're taking a look at a specific question, and we're trying to take a look at a couple of different methods of how we can use rates to solve this particular question. So the first one that we're going to look at, or the first method, is to look at how we solve something using proportions. So let's take a look at the question. Amelia walks briskly at 6 kilometers an hour. When she walks at this rate for 2 hours, she burns 454 calories. Bruce walks at a slower rate, 4 kilometers an hour, burning 62 calories in 30 minutes. Now, if Amelia walks for 3 hours, how much longer will Bruce have to walk in order to burn the same amount of calories? Now, one of the first things you need to do when you're looking at a question like this one is focus on the question that you're being asked and try to determine what are the things they're asking you to find. So you take a look at it, it says how much longer. So we're being asked to find time. And then it says, in order for him to burn the same amount of calories. So we're looking for a relationship of calories to time. So when I start out my question, then I'm going to start by suggesting that I use the following pattern, where I put calories in the numerator and hours in the denominator. Now, if you need to go back and forth between the question to collect and check to see what the numbers were, please do that. But let's go ahead and take a look at the solution. Let's look at Amelia first. Now, we're told that she burns 454 calories in 2 hours. So you'll see the calories are on top and the hours on the bottom. Then we need to figure out how many calories she burns when she walks for 3 hours. So I'm putting 3 in the position of the hours and an X in the position of the calories because I do not know what the calories are. Then I'm going to cross multiply. 3 times 454 is equal to 2 times X. Once I have my algebraic equation set up, I know that I need to get X by itself. So I divide by 2 on both sides of the equation. Pick up my calculator, use it, and discover that she will burn 681 calories in those 3 hours that she is walking. Next, Bruce. Now, Bruce burns 62 calories in 30 minutes, but you will notice that I did not write it as 30 minutes because I suggested that I'm going to use hours in that spot. So I needed to write down that this is half of an hour, 0.5. Now, I'm looking for how long it's going to take him to walk the same amount to burn the same amount of calories. So X is in the time position and the calories are 681. Use your cross multiplication, use your calculator, and you should be finding that Bruce will take basically 5.5 hours to catch up to what Amelia has burned. Now, one thing you do need to notice about this question is that it says, how much longer will Bruce have to walk in order to burn the same amount of calories? So that means if he has to walk 5.5 hours and she walked 3, that Bruce has to walk 2.5 hours longer than Amelia. Now, that was the method we call using proportions. You can also solve the same problem by creating something called a linear function. Now remember, linear functions are where you have y is equal to mx plus b, where the m is the slope. And what we're looking at in that is talking about how the rate of change, we're focusing on the rate of change in these particular questions. So let's see how that applies. Well, first of all, if you think about what's happening here, and we're talking about the rate of change, well, we're thinking about how many calories does Amelia burn as time passes. So we know it's 454 calories in 2 hours. And if we change that into a unit rate, we know that she's burning calories at 227 calories an hour. That is the rate at which she is burning calories. So I'm going to create a linear function with that in mind. I'm going to call it A for Amelia, and we're going to do it in relationship to time. So A with respect to time is equal to her rate of change, which is 227 times time. If you consider what we've done there, you know that if the time is 1 hour, she'll burn 227 calories. If the time is 2 hours, she'll burn 454, and so on. We have a function that is giving to us how many calories that Amelia burns. Now we're going to do the same thing for Bruce. So we know that it's 62 calories in 30 minutes. Well, I don't want to keep it at 30 minutes. So here you can see me using the unit conversion to get rid of, so cross out the minutes and find out what it is for 1 hour. So it comes out to be that his rate of change, constant rate of change, is 124 calories per hour. So I'm going to write a linear function that describes Bruce, B for Bruce. So Bruce's calories that he burns as time passes is equal to 124 times t. So what we have now are two functions that describe, one describes Amelia, one describes Bruce. Now let's set out to solve it. First of all, we want to take the function that figures out how many calories Amelia burns, and we want to figure out what it will be when she has used up the time of 3 hours. So we want a of 3. Plug in the 3, we get 681. Now with Bruce, we want to know what T is. So T is the one we're looking for. We plug in at the calories he burns, it would be 681. And then you get your number, 5.491 or 5.5. So Bruce will need to walk 5.5 hours, but remember the question said how much longer. So it would be 2.5 hours longer than Amelia. Okay, now there you have it. Those are basically the two styles of strategies that we use for solving these types of questions. Make sure you take a look at the homework, which was focusing on section 8.2. You'll find in a lot of the solutions that I use proportions a lot. I find proportions to be very straightforward, well organized, but please feel free to try using the linear function method as well. Bottom line, make sure you do practice it and that you bring any questions you have to class. Good luck, everyone.